Hello everyone, I am Marcos Pelayo and today I will be talking about manometers. What is a manometer? A manometer is a scientific instrument used to measure gas pressures. Open manometers measure gas pressure relative to atmospheric pressure. A mercury or oil manometer measures gas pressure as the height of a fluid column of mercury or oil that the gas sample supports. Many techniques have been developed for the measurement of pressure and vacuum. Instruments used to measure and display pressure in an integral unit are called pressure meters or pressure gauges or vacuum gauges. A manometer is a good example as it uses the surface area and weight of a column of liquid to both measure and indicate pressure. Pressure, or the intensity of pressure, is defined as force per unit area, or P equals F over A, where P is measured in Newton per meter squared. Fluid pressure is measured with respect to varying individual reference that is device or procedural specific. When it is measured with respect to absolute zero, or complete vacuum, it is called absolute pressure. When it is measured either above or below atmospheric pressure, it is called gauge pressure. Absolute pressure is zero reference against a perfect vacuum using an absolute scale, minimum or 0 point. So it is equal to gauge pressure plus atmospheric pressure. Gauge pressure is zero reference against ambient air pressure, so it is equal to absolute pressure minus atmospheric pressure. Differential pressure is the difference in pressure between 2 points. We'll proceed to types of manometers. The first type is the U-tube manometer. This type of manometer is U-shaped, with one end open to atmosphere. It is used for measuring suction. It has the capability of measuring both positive and negative suction pressures. It utilizes the principle of specific gravities for measuring the suction pressure. This type of manometer generally has a liquid whose specific gravity is greater than that of the fluid whose suction pressure is to be measured. The second one is differential U-tube manometer. This type of manometer is slightly different from the normal U-tube manometer. Here, the open end is also closed. What that means is both the ends of this type of manometer are closed. It really becomes a tool of importance where the pressure is to be measured directly. This manometer type has fluid or liquid filled at different pressures on both ends. The third one is the inverted U-shaped tube. This type of manometer, as the name suggests, has an inverted U-shaped tube. It is used to measure differences in low pressure between 2 points, where the high level of accuracy is desired. It is filled with the liquid on the ends. The space between liquids is filled with air. This air can be expelled or admitted into the apparatus using a tap. This is done to adjust the pressure difference to obtain an accurate reading. The fourth type is micromanometer. Micromanometer is a great tool used in fluid statics. It is a modified form of a simple manometer. It has one limb which is larger in cross-section. It is a device which is used to measure very minute pressure difference with high accuracy. The next type is the inclined manometer. This is a high precision and high accuracy type of a manometer. It is used to measure the minuscule amount of pressures with high accuracy. Its configuration is inclined and this makes it more accurate than other types of manometers. It is used where manometric properties of liquids are very close. So the last type of manometer is the sphygmomanometer. This is an instrument for measuring blood pressure, typically consisting of an inflatable rubber cuff which is applied to the arm and connected to a column of mercury next to a graduated scale. enabling the determination of systolic and diastolic blood pressure by increasing and gradually releasing the pressure in the cuff. Sphygmomanometers, we can mostly see this in hospitals and clinics used by the doctors.
Measuring liquid pressure. An instrument called manometer is used to measure liquid pressure. It consists of a glass U-tube fixed to a stand with a scale. It is half filled with water. One end of the U-tube is open. The other end is attached to a thistle funnel through a flexible tube. The mouth of the thistle funnel is covered with a tight, thin rubber skin. When the thistle funnel is kept in the air, only atmospheric pressure acts on it. This is equal to the pressure acting on the open end of the U-tube. Therefore, the water levels in the two sides of the U-tube remain the same. Dip the thistle funnel in a bucket of water. Now, the liquid pressure acts on the rubber skin. As the liquid pressure on it increases, the water level in A will go down and in B will go up. The difference in water levels can be read on the scale. This is a measure of the pressure
So that's it, guys. Hope you learned a thing or two, and thank you for listening. Stay in school.